Okay, this is a step-by-step approach for solving a linear programming problem. I'm going to have you pause. I'm going to have you write this down. You will need this in your notes. I'm going to explain. This will make a whole lot more sense when we actually go through an example. So the first thing you have to do is write the objective function and write the system of constraints. Some of the homework problems that I gave you already have the objective function written. They already have the constraints written. You can skip step 1. Some of the homework problems you actually have to do this step. You have to write the objective function. You have to write the system of constraints. Second thing you have to do is graph the system of inequalities, the constraints. And the third thing is where you take and find each corner. You have to find the corner of the shaded region. So corner of the shaded region, we call that the vertex or vertices. And you're going to take these vertices and you're going to plug them into the objective function. Now, depending on whether we're looking for the maximum or the minimum, once we plug it into the objective function, that's z. So we have z equals. We're either looking for the largest z value or the smallest z value. And that would be your answer. So once you find the largest z value, if I'm asking for the maximum, then you would say the maximum value is such and such. The Wisconsin paper mill can convert wood pulp to either notebook paper or to newsprint. The mill can produce at most 200 units of paper per day. That's between the paper and the newsprint. So at most think that you have to be less than that. So we can do 199, we can do 200, but we cannot do 201 units of paper. At least means we have to do that many or more. So I can do 10 units, I can do 11 units, I could do 12 units, but 8 units isn't going to work. So we need at least 10 units of notebook paper and at least 80 units of newsprint. We're going to let B represent the notebook paper and N represent the newsprint. Okay, so this right here, this first paragraph, is setting up, it's going to tell you which variables to use. It's going to give you the constraints. You have to actually write the constraints, the inequalities. The last sentence, or 2 sentences in this case, will give you the profit function or the objective function. Usually we're trying to maximize, make the most profit. So sometimes we call it objective function, sometimes we just get careless and call it a profit function. So the profit function or the objective function is usually going to come in the last sentence or 2. So the first thing we need to do is write an objective function. Well, that is the profit that comes from this paragraph at the bottom. So we make a profit of $500 on a unit of notebook paper. So for every notebook paper I sell, I'm going to make $500 profit. So that's a rate. Whenever you have the profit functions, these are always going to be rates. They always have to get multiplied times the variable. The notebook paper, we called that B. So my profit function, I'm going to call it P for profit. I'm going to have 500 times B. I'm also going to sell newsprint. and I make a profit of $350 on newsprint. So that's $350 for every unit of newsprint. So for each, it's a rate. You take the 350, you have to multiply it times the variable, which is n. So 350 n. So this is the objective function, or the profit function. Also says write the system of constraints. Alright, I told you the constraints came from the first paragraph. And it says the mill can produce at most 200 units of paper per day. That's the notebook paper and the newsprint together. So if I take the notebook paper and I take the newsprint, that can be at most 200. So my notebook plus my newsprint has to be less than or equal to 200. They also said at least 10 units of notebook paper. At least means I have to have 10 or more. So my notebook paper has to be 10 or more. So my notebook paper has to be greater than or equal to 10. We need at least 80 units of newsprint. So at least we need that many or more. So we have the newsprint. We have to have at least greater than or equal to 80 units. So 80 units of newsprint. So I have my objective function. The objective function is always going to be equal to, it's going to be an equation. And then I have my constraints. Those are going to be the inequalities. The second step says graph the inequalities. Don't graph the equation. Do not graph the equation. Graph the inequalities. Remember, when you're graphing inequalities, you're going to pretend it's equal. You're going to do solid or dotted. I'm going to give you a hint with linear programming. It's always going to be a solid line because it's always going to be less than or equal to or greater than or equal to. I've never seen a linear programming problem that was less than or greater than, so you don't have to worry about the dotted line. And then you have to do the shading. Don't forget the shading. So we have to graph the inequalities. So I have b plus n is less than or equal to 200. So b plus n is less than or equal to 200. It's in standard form. So I'm going to do my intercepts. I'm going to let n equal 0. If n equals 0, I plug in 0 for n. I get b equals 200. And I'm going to let b equals 0, and I'll get n equals 200. It's going to be a solid line because of the less than or equal to. So I'll point here at 200, point here at 200. Something I didn't mention before, but the first variable that we talk about is always the x variable, if you will. So the first variable we talked about was the newsprint, or b. That's always going to go along this axis right here. The second variable we talked about was the newsprint, and so that is going to go in this direction. So anyway, my we've got our 2 points. We're going to connect them, preferably with a straight line. Let me undo that and let's try again. A little bit better. And I need to shade. So with shading, you pick your test point. In this case, I'm going to pick 0, 0. Remember, you can pick any point you want to, as long as it's not on the line. So I'm going to put 0 in for B and 0 in for N. And is that less than or equal to 200? Yes, it is. So I'm going to shade over top of my 0, 0. Remember to shade lightly because you will have to erase. So that's the first inequality. Second inequality is B is greater than or equal to 10. So I have B is greater than or equal to 10. Notice I just have the variable B. I don't have a B and an N. So it's either going to be a vertical line or a horizontal line. Well, the B axis is going this way. So B equals has to go opposite. It's going to be a vertical line. So B greater than or equal to 10 has to be a vertical line, solid, at 10. Okay, you can either do a test point or you can just think about this. We need to be larger than 10. Larger than 10 is to the right. So I'm going to shade to the right. And remember, what we're looking for is the overlap. So while I can shade out here, I'm not going to, because I already know that I'm going to have to erase it because I'm looking for the overlap. And since there's no red over here, I would just have to erase it anyway, which I'm going to do now. And I'm going to erase this red down here. Get rid of that red. Okay, so that's my second inequality. And then I believe the last one was N is greater than or equal to 80. So N is greater than or equal to 80. Again, I just have the N, I don't have the N and the B, so it's either going to be vertical or horizontal. I already did vertical, so this one must be horizontal. Solid line again, because it's equal to. Has to be greater than or equal to. Larger than 80. Larger than 80 is shading up. Again, you can do the test point, but you shouldn't need to bother with that. And I'm going to erase any of the shading that is not overlapped all three places, all three colors. So I didn't have any green down here, so I'm going to erase all this. So the second step takes a while, but graph the system of inequalities. So we have the system of inequalities. The final step, we're going to find each of these points, the corner points, the vertices. Notice I have 3 sides to this shaded region. Doesn't matter how many sides there are, as many sides there are is going to be the number of vertices that we're going to have to find. So if I had some weird, crazy shaded region like this, 1, 2, 3, 4, 5 sides, I would need 1, 2, 3, 4, 5 points. So the number of sides gives you the number of vertices that you're looking for. So 3 sides, I need 3 points. So you actually have to figure out what those points are. If you're really lucky, they will be where a horizontal and or a vertical line crosses. We know what the B value is here because it's a vertical line. That was a vertical line at B equals 10. So this point, this one right here, is going to have a B value of 10 because it's on that line. B is equal to 10. The horizontal line was at n equals 80. So at this point, the n is going to equal 80. The rest of the points are easy, but not quite as easy. So this point right here in the purple, again, it was on the line where b was equal to 10, so I already know the b value. To find the n, you're not going to guess. You're going to actually have to plug it in. So you have to remember where this line came from, because that's what we're looking for, is where those two lines cross. The equation for this line was b plus n is, I'm going to say equal to 200. It was an inequality, but I'm looking for the line, not the shaded region, so I'm going to say equal to 200. So where those two lines cross, that vertical line, b equals 10, and this line where they cross, well, I know the b has to equal 10. I already know that from this right here. So if the b equals 10, and I solve for n, I subtract 10, I know the n has to equal 190. So far, I have the points 10, 80. I have the point 10, 190. And I've got one more point that I need to find. It's this one right here. Now, I don't know what my b value is, but it is on the line n equals 80, so I know the n value has to be 80. And it's also on that line b plus n is equal to 200. So I know what the n value is. B plus 80 equals 200. Subtract 80. So b has to equal 120. Don't go by the graph. You actually have to figure it out algebraically. So we've got 120, 80 is the third point. Alright, now I have those 3 points. What I need to do is take these 3 points and I need to plug them into my objective function. My objective function, see if I can remember what it is, 500 b plus 350, and let me check that real quick just to make sure I got that right. 500b plus 350n. Yep. So what you need to do is plug each of these points in to this P function. So the first point has a B value of 10 and an N value of 80. So the first point I'm going to plug in, I have 500 times 10 plus 350 times 80. Without a calculator, I'm not going to be able to do that in my head, but you would do that in your calculator to figure out what that value is. And when I go to the next slide, hopefully I have that information, otherwise I'll try and find a calculator. I need to plug in the second point the same way. P is equal to 500 times 10, we're doing the second point now, plus 350 times 190, and figure out what that value is. And you also need to do the last point. P is equal to 500 times 120 plus 350 times 80, and figure out what that number is. We're trying to maximize the profit, so whichever these numbers is the largest, once we actually calculate it in the calculator, that would be our answer. Okay, first point we had 33,000, second point we had 71,500, and the third point we had 88,000. So with linear programming, we either want to find the maximum or the minimum. And if you look at the 33,000, the 71,000, the 88,000, 88,000 is the biggest number. So the answer would be 88,000. And we would make, I'm going to put that on new slide so we can actually see what we're doing. So our profit would be 88,000. And we would make 120 notebooks. And that was 80 newsprint. So your answer would be 88,000 with 120 notebooks and 80 units of newsprint. Your homework for this section is 2 through 8 even. I also want you to do number 14.